Thank you for joining me for this presentation on the tekmarNet Thermostat 557. My name is Elizabeth Brown. I am a technical support specialist at Tekmar Controls, and I will be hosting today's webinar. The 557 is a configurable thermostat with up to 4 stages of heat and 2 stages of cool with fan and humidity control. It is the only thermostat on the market designed to operate a 1 or a 2-stage water-to-air or air-to-air heat pump together with a radiant floor. This is the second webinar on the 557. If you missed the first presentation, it is available for viewing on our website, www.tekmarcontrols.com. I highly recommend you start with the first webinar. It is an introduction to the functions and the target applications of the 557. This is intended to be a Level 2 presentation, and will go more into depth on the wiring and the settings, so that you can decide if the 557 is the right choice for your application, and if it is, how to set it up accordingly. This is the outline for today's presentation. We're going to start with humidity control settings. Relative humidity is a bit of a complex concept, so we're going to unravel it together today. We'll also revisit the 5 applications of the 557 as featured in the application brochure and as outlined in the first webinar. But we're going to go into greater detail on the wiring and the essential settings in the setup menu that are specific to each of those applications. Lastly, we'll review the menus of the 557 with a particular focus on the set temp and the toolbox menus to introduce the settings that may enhance the performance of your system. These are the 5 applications of the 557 that were featured in the introductory webinar. The top 2 applications are traditional heat-cool equipment applications, and the bottom 3 applications are heat pump applications with the 557. The first traditional equipment application features a furnace and an air conditioner. We have a single stage of heat being provided by the furnace, and we have up to 2 stages of cooling from our air conditioner. We also have a humidifier in the ductwork to provide some humidity control. Our second traditional equipment application features a radiant floor and fan coil plus an air conditioner. We have a first stage of heat from the radiant floor, a second stage of heat with the fan coil, and up to 2 stages of cooling with the air conditioner. We again have the humidifier in the ductwork for humidity control. Our first heat pump application shows including the option of a radiant floor, and that's why it's outlined in the dashed red line. It is optional. If we do include the radiant, that is our first stage of heat. Our heat pump can provide an additional 2 stages of heat, and we have an electric strip backup which can provide a 4th stage of heat. When we switch over to cooling mode, our heat pump can provide up to 2 stages of cooling. Again, we have the humidifier in the ductwork for humidity control. Our second heat pump application features a building loop heat pump. So we have a loop throughout the building that's maintained within a certain temperature range from a boiler and a cooling tower. And in individual units of the building, there are water-to-air heat pumps. Again, we have the option of the radiant floor. That's why it's outlined in the dashed red line. If we include the radiant, that's our first stage of heat. Our heat pump will provide a 2nd and 3rd stage of heat, and a 4th stage of heat is possible with the electric strip backup. When we switch over to cooling mode, we have up to 2 stages of cooling from the heat pump. Our last heat pump application features a water-to-water heat pump, and as discussed in the first webinar, this requires the pairing of the 557 with the 406 house control. A first stage of heat is provided by the radiant floor, 2nd stage of heat through the fan coil. When we switch over to cooling mode, the fan coil becomes a 1st stage of cooling, and we have the option here of doing radiant floor cooling. One thing I want to clear up is a question that we have had asked at Tekmar. How many heat stages are possible? When can we have 3 or 4 stages of heat? And the answer is only with a ducted heat pump system. So an example where we have 4 stages of heat is shown on the left-hand side. where we have radiant floor as first stage heat, a heat pump providing a second and third stage of heat, and an electric strip backup providing a fourth stage of heat. If you look at the example on the right, it is strictly a hydronic system, and only two stages of heat are possible, the radiant floor and the fan coil. We cannot control an electric strip backup in this situation with the 557. The 557 measures and displays relative humidity, which is a term we're all familiar with, but maybe we're not all 100% clear on. What exactly is relative humidity? Well, it's the moisture content in the air compared to the potential moisture content in the air at the given temperature. And to appreciate this, we need to understand that as the air temperature rises, the potential moisture content increases. As shown in the illustration, air at 80 degrees Fahrenheit can contain a lot more water vapor than can air at 10 degrees Fahrenheit. And that has to do with the thermal energy that's available for the water molecules to evaporate. If we took this amount of water for a given airspace, at 10 degrees Fahrenheit, it would result in 100% relative humidity. If we warm that air up to 80 degrees Fahrenheit, that same amount of water in the same airspace could result in a relative humidity of only 10%. So relative humidity is meaningful because it provides the context based on the air temperature of the room. Now that we know what relative humidity is, how do we control it? Well, we control it with the minimum and maximum humidity settings in the 557. We can configure a relative humidity minimum ranging from 20 to 80%, or we can turn it off if we don't have a humidifier. The default in the 557 is 40%. If we drop below the humidity minimum setting, we may notice dry skin, dry eyes, maybe difficulty breathing. Our kids might get nosebleeds. It's very uncomfortable. So we are going to enable the humidifier. The humidifier would be enabled whenever the humidity drops below that minimum setting, and it will turn off when we are 5% above the minimum setting. Similarly with the maximum, we can configure it to 20 to 80%, or turn it off if we don't have a dehumidifier. The default in the 557 is 60%. If the humidity rises above that maximum setting, we may notice condensation on the windows. We might be worried about mold and bacteria. So we are going to enable a dehumidifier. The dehumidifier will turn on whenever the humidity rises above that maximum setting. And it won't turn off until we are 5% below the maximum setting. So the relative humidity is maintained with a 5% differential above the minimum and below the maximum. As we discussed, relative humidity depends on temperature. So what happens at night if we set back? Let's look at the example. During the day, our air temperature is 72 degrees. And for the given amount of water vapor in the room, that could give us a relative humidity of 50%. If at night we drop down to 65 degrees Fahrenheit, that same amount of water vapor in the air would give us a relative humidity of 64%, because colder air can contain less water vapor. Now, if we used this value for relative humidity, it would probably trigger our dehumidifier to operate if we kept the default humidity maximum setting of 60%. So we would enable the dehumidifier and remove some of that water vapor from the air. Well, then what happens the next day as it heats up? That lower water vapor content might be below our relative humidity minimum setting, and then we would be enabling our humidifier. So we'd be encountering some back and forth inefficient operation of the dehumidifier and the humidifier, when what the goal is to keep the moisture content in the room stable. We don't want to be adding or removing moisture as a reaction to the change in air temperature in the unoccupied state. So what the 557 does is it ignores the temperature of the unoccupied state, so it ignores that setback temperature, and instead calculates relative humidity based on the occupied set point temperature. We also use relative humidity for the dew point calculation. And this dew point temperature is necessary for two operations, for radiant cooling and to operate an HRV. For radiant cooling, we're going to be pairing the 557 with the 406 house control. And in this case, the 406 house control will be using the relative humidity measurement provided by the 557 to do the dew point temperature calculation in order to reset the water temperatures for radiant floor cooling, making sure we avoid condensation. We talked about this operation in greater detail in the first webinar, so feel free to refresh by looking at that first webinar again on our website. To operate an HRV, the 557 does the dew point calculation. And we're only going to operate that HRV if the outdoor temperature is at least 5 degrees below the indoor dew point. We're going to discuss that in greater detail when we go over the dehumidification modes of the 557. There are 3 humidification modes in the 557. The first, mode 1, is for a standalone humidifier. An example would be a console unit that has its own fan to blow air through a wet medium and into the space. If a unit like this did not have its own humidistat, the 557 could enable it as we needed humidification. Humidification mode 2 is a humidifier that requires a fan. So this type of humidifier can provide humidity without using the heat from your system, but it does need the system blower to move the water vapor through the building. An example of this is a steam injection humidifier, where water is boiled and injected into the duct, and then carried throughout the building through the ductwork by the system blower. So this humidification mode can be operated year-long because we don't need to use or rely on the air heating from our HVAC system. The third humidification mode is a humidifier that does require air heating. An example would be a bypass humidifier, where heat from the system bypasses through a wet medium, collects humidity, and then transfers that humidity to the building through the ductwork. This is probably the most popular humidifier, but you are limited by your heating cycles. You cannot operate this year-round. There are 5 dehumidification modes. The first mode, mode 1, is for a standalone dehumidifier. And an example of that would be a compressor-driven consoil. And they have their own fan to pull air over 2 sets of refrigerant-filled coils to condense the water vapor out of the air. Dehumidification mode 2 is for coil dehumidification. Now, in this case, air passes over the cold coil, and the water vapor condenses, and the outgoing air becomes cooler and drier. Clearly, this is not available during heating. We have to be cooling for this to be possible. And it does require a duct sensor to make sure we don't freeze our coils. Dehumidification mode 3 uses an HRV, and it exchanges stale indoor air with fresh outdoor air. It only works to dehumidify the air if the outdoor air is colder and drier than the indoor air. And this happens, as we discussed earlier, if the outdoor temperature is at least 5 degrees below the indoor dew point. So typically this kind of condition is only present in the winter. It will not address moisture problems during other times of the year. Dehumidification mode 4 combines the operation of an HRV with a standalone dehumidifier. And this would be selected if we want to use the HRV when we can't, typically in the winter months. And then if we need dehumidification during other times of the year, we could use the standalone unit. Dehumidification mode 5 is a similar concept. We're going to use the HRV when we can, typically in the winter, and then we can use the coil during the other times of the year when we're in cooling mode. So it's kind of the perfect pairing. We have a dehumidifier for cooling mode and one for heating mode. To elaborate a little bit more on the coil dehumidification, you can see in this picture we're showing a temperature in the ductwork of 45 degrees, and this acts like a limit. If the air temperature in the duct falls below 40 degrees, we're actually going to turn off the compressors and not allow the dehumidification operation. So we're going to try and stay around 45. If it drops below 40, we turn off those compressors. We're also allowing the air temperature to fall up to 3 degrees below the set point. Because that air coming out from the dehumidification operation is going to be colder, it will fall a little bit. We'll allow it to fall up to 3 degrees before we turn off the compressors. Dehumidification with an HRV, as I said before, is possible if the outdoor air is at least 5 degrees below the indoor dew point. So the 557 will do the dew point temperature calculation based on the relative humidity of the room and based on the temperature of the room. And if the outdoor temperature is at least 5 degrees below that indoor dew point, the HRV can turn on. Once the outdoor temperature is 2 degrees below the indoor dew point, we're going to turn the HRV off. But you can notice that we have actually managed to decrease our relative humidity from 62% to 51% while that HRV was operating. So it is a very effective mode of dehumidification when conditions allow it to operate. We're going to jump now to our applications. Application number 1 is our forced air application with traditional heat-cool equipment. We have a single stage of heat being provided by our furnace, and that's being controlled through the W2 relay. When we're in cooling, we have up to 2 stages of cooling provided by our air conditioner, controlled through the Y1 and Y2 relays. Of course, we need the fan to operate, controlled through the G relay. You can also see a humidifier in the ductwork. It says HUM here, just to represent that this is a humidifier. It's actually controlled through the accessory relay. Taking a look at the wiring here, we have the humidifier being enabled through the accessory relay. And then we have our connections to the furnace and air conditioner. W2 to the furnace, Y1, Y2 for the stages of air conditioning. R and C are power and common, and G for our fan. Now let's trace these wires. We have our 24 volt R coming from the unit into the 557, connecting up here to the R, and that's being jumpered to RH2, which is connected to the W2, and then back to the furnace. Y1, Y2 are straight connections over to the 557, as is our G, and our common is going straight to the common on the 557. We've also connected an outdoor sensor to the sensor 2 terminal. An outdoor sensor is not necessary for this operation, something that would likely be desired by the residents. We've shown it on the mechanical, so we're showing it on the wiring diagram. Here are the essential settings for this application. Sensor 2 is being configured for the outdoor sensor. It's not going to sensor 1 because sensor 1 cannot be configured to be an outdoor sensor. W1 terminal is being set to none. The reason that's being set to none, let's look at the setting options. Our only options are for a high mass radiant floor or a low mass radiant floor, or other. So we're not going to control the furnace through the W1 terminal. We're going to control it through the W2 terminal, which we can configure to operate a furnace. Our Y1 and Y2 relays are the stages of air conditioner. Our accessory relay is controlling the humidifier, and because this humidifier is in the ductwork, it's going to be humidify mode 2 or 3. It is not a standalone humidifier. Our second application with traditional heat-cool equipment is a radiant floor with a fan coil and an air conditioner. Our first stage of heat is the radiant floor. That's going to be controlled through the house control. Our second stage of heat is the fan coil. And if we're in cooling mode, we have up to 2 stages of cooling, controlled through the Y1 and the Y2 relays. Again, we see a humidifier in the ductwork to provide some humidity control. Taking a closer look at the wiring. Because we're going to be connecting to a house control for that radiant heat operation, we're going to connect the TN2 terminals over to our house control. And so that first stage of heat is going to be communicated through the TN2. Notice there are no wires at RH1 or W1 because that first stage is all communicated through the TN2. Our second stage of heat will require us to bring the RH2 and W2 over to a tekmarNet 4 wiring center. So that will go to the W and the R for zone 1 on a tekmarNet 4 wiring center. We have the humidifier being controlled through the accessory relay, and we have our connections to the air conditioner. Power coming in, our Y1 and our Y2 connections for each stage of compressor, and the fan, of course. Taking a look at our essential settings, this time we do have a radiant floor, so we're going to configure the W1 terminal for HRF 1 or 2, depending on whether it's a high mass or a low mass system. In this case, our backup W2 terminal is set to coil. And whenever we're setting up our backup W2 terminal to a hydronic system, we have to program what the W2 source is going to be. In this case, it's high temperature. We're setting that source to boil. Our Y1 and Y2 relays are controlling the stages of air conditioner. Accessory relay is controlling the humidifier. And because that humidifier is in the ductwork, humidify mode is 2 or 3. Our third application and our first heat pump application is a radiant floor, which is optional. It's optional, shown in the dashed red line. If we include it, that's our first stage of heat. Our second stage of heat is from the heat pump, operated with the Y1 relay. Our third stage of heat is also from the heat pump, operated with the Y2 relay. And we have a possible fourth stage of heat with the W2 relay that controls an electric strip backup. When we're in cooling mode, we have up to 2 stages of cooling with the Y1 and the Y2. And in this case, we would power the O for the reversing valve. Notice we have a humidifier in the ductwork that is going to be controlling our relative humidity. Taking a closer look at the wiring, if we do include that radiant, then we're going to be communicating that call to a TN2 house control. So the house control will be operating the valves and the pump for the radiant, and that hydronic call is communicated through the TN2 wires. Notice again, we have nothing on RH1 or W1. Our second and third stages of heat from the heat pump are going to be controlled with the Y1 and the Y2 connections. We also have the power coming in from the heat pump. We're connecting our backup heat, W2, at the heat pump as well. And we have our fan operation and O for the reversing valve. So let's trace some of these wires. We have power from the heat pump coming in. We're bringing that up to our RH2, which is connected to W2, and coming over to the backup heat. R is also powering the Y1 and the Y2, as well as the fan, and we will use the O when we want to switch over to cooling mode. These are the essential settings of this application. Again, if we are configuring it for a radiant system, the W1 terminal will be set for HRF 1 or 2 depending on the mass of the radiant floor. Our backup W2 terminal will be set to furnace, and this is because we need the fan operation for that electric strip backup. Y1 and Y2 relays are set for the heat pump stages 1 and 2. Our accessory relay is again set for the humidifier. Now we have to tell the 557 what the source is for our heat pump. In this case, it's an air source heat pump. And because that humidifier is in the ductwork, the humidify mode is 2 or 3. Here is an alternative with an HRV. Similar to the application we just saw, we have a first stage of heat from the radiant floor, a second stage of heat at the heat pump controlled with the Y1 relay, and a third stage of heat, the electric strip backup, controlled with the W2 relay. Notice here it's a single stage heat pump. We're restricted to using a single stage heat pump because our Y2 relay will be controlling the HRV. When we're in cooling mode, we have one stage of cooling from the heat pump, and we are showing the humidifier in the ductwork. Let's look at the wiring. We see those TN2 connections to a house control for the radiant operation. So the house control will be controlling the valves and the pump for the radiant. Our second stage of heat is at our heat pump. We have the Y1 connection only. So R comes in from our heat pump and is going to the Y1. We have the fan, obviously, and O for the reversing valve to switch into cooling mode. Now let's look at our HRV. We have R coming in from the heat pump because Y2 is not an isolated relay. It's connected to that R from the heat pump. Y2 goes over to the HRV, and to complete that circuit, the common has to tie back to the common on the heat pump. Our third stage of heat, the backup electric strip, it is an isolated relay, so it's a simple connection, RH2, W2. The essential settings for this. Now in this case, we absolutely require an outdoor sensor, because if you remember, the HRV can only be operated if the outdoor temperature is at least 5 degrees below the indoor dew point. So we're going to configure sensor 2 for our outdoor sensor. Our W1 terminal will be set to HRF 1 or HRF 2, depending on the mass of the radiant. Our backup W2 terminal, that electric backup strip, will be set to furnace for the fan operation. Our Y1 relay will be set for our heat pump. This time Y2 relay will be set for the HRV. Again, the accessory relay is going to be controlling a humidifier. It is an air source heat pump. Because the humidifier is in the ductwork, we're going to be using humidify mode 2 or humidify mode 3. And now that we are using an HRV for dehumidification, we will set our dehumidification mode at number 3 for the HRV. Our second heat pump application, the fourth application overall, is the building loop, heat pump, and backup. Again, we have the option of including a radiant floor, noted as optional with the dashed red line. If we include the radiant in the system, that is our first stage of heat. Notice this time the 557 is not going to a house control for that radiant operation, it's going to a TN4 control. And that's because this type of application is really seen only in commercial situations where we wouldn't likely use a house control. We're more likely to use the designer series. We have a building loop being maintained within a certain temperature range by the boiler and the cooling tower. And there are individual heat pump units. So our first stage of heat is the radiant, second and third stage of heat provided by the heat pump with the Y1 and the Y2 connections, a fourth stage of heat with the electric strip backup, and when we switch over to cooling, we have two stages of cooling with the Y1 and the Y2 heat pump connections. So this type of application, usually seen in hotels or conference centers, multifamily residences, apartment buildings, where each unit has its own water-to-air heat pump so that each unit has individualized temperature control. Some can be in heating, some can be in cooling. Taking a look at the wiring, because this time we are not connected to a house control, we're connected to a TN4 system control. We have our TN4 wire over to our control and our C to the TN4 control. R is coming in from the control to R in the 557. We're jumping it to RH1 and then bringing W back to the TN4 system control. Our heat pump connections. We have the R from our heat pump coming into the 557. We have our Y1 and Y2 connections at our heat pump. O for the reversing valve and G for the fan. Notice here as well that this time the accessory relay is controlling a building loop zone valve. So we have R from our heat pump coming in, coming up to RH2, and then jumped over to the accessory relay. Accessory relay brings that connection to the zone loop valve, and then the C comes back to the heat pump to complete the circuit. For that backup electric strip, we have, again, R coming in from the heat pump up to RH2, which is connected to W2, W2 back to the heat pump for the operation of the electric strip backup. Here are the essential settings for this application. If we include the radiant, W1 terminal, HRF 1 or 2. The backup W2 terminal is set to furnace for the electric strip. Y1 and Y2 relays are configured for our heat pump stages 1 and 2. This time our accessory relay is controlling the valve, and the heat pump, it's a loop. Our last application shows a water-to-water heat pump. And again, this application requires you to pair the 557 with the 406 house control. So we have our water-to-water heat pump that will keep this buffer tank with either heated water or chilled water, depending if we're in heat or cool mode. If we're in heat mode, then we have our first stage of heat with the radiant, our second stage of heat with the fan coil. If we switch over to cooling mode, this tank will be filled with chilled water. Our fan coil will be first stage cooling, and we have the option of doing radiant floor cooling as well. There is also a humidifier in the ductwork for some relative humidity control. Taking a look at our wiring. Because we're connected to a TN2 house control, we have our TN2 connections from the 557 to the house control. Our second stage of heat, the fan coil, we have to bring the RH2 and W2 connections over to a tekmarNet 4 wiring center, to the R and the W on the wiring center. Our accessory relay is controlling the humidifier as shown in the ductwork. And this time we're also going to use the fan coil for some dehumidification. It's there, let's use it for dehumidification. So we have our R from the fan coil coming in, and the Y2 being used to enable the dehumidification, and of course the fan with the G. We do need a duct sensor if we're going to be doing coil dehumidification to make sure those coils don't freeze. And we also show a connection to a slab sensor to give us some control with radiant floor cooling and for radiant warming as well. The slab sensor is not required, it just provides us the option of having some better control over that system. Here are the essential settings. Sensor 1 will be configured for the duct sensor, and sensor 2 would be configured for the floor sensor if you're using that slab sensor. Our W1 terminal is set for our radiant floor. Backup W2 is set for coil. And again, it's hydronic, so we have to specify the backup W2 source. In this case, it's coming off the tank, so tank is our source. Our Y1 relay is going to be configured for W2 because our first stage of cooling is that fan coil. Our Y2 relay will be configured for dehumidification. Our accessory relay configured for the humidifier operation. Because that humidifier is in the ductwork, that is humidify mode 2 or 3, and our dehumidification mode is 2 for the coil operation. I want to look at some other settings that are not essential settings but will enhance the performance of your system. The first we're going to look at are the Y2 and W2 differential settings. If W2 is the only source of heat, so for an example would be when we're using that W2 relay to control a single stage of furnace, then you cannot specify the differential. The differential will be fixed, and it is 1 degree below set heat room and 1 degree above set heat room. So W2 relay will turn on when we are 1 degree below, and it'll turn off when we're 1 degree above. If we are using W1, W2, Y1, and Y2, so an example of this would be radiant floor as first stage, heat pump as second and third stage, electric strip backup as fourth stage. Our W1 will be operating with PWM, pulse width modulation. Our second stage of heat, our Y1, has a fixed differential of 1 degree. So when we are 1 degree below that set heat room, our Y1 will be enabled. Our Y2 differential can be programmed. You have a 0 to 4 degree range. So Y2 will turn on when we are 1 degree plus the Y2 differential below the set heat room setting. And it won't turn off until we reach the set heat room setting. Our W2 differential is also configurable. It goes from 0 to 8 degrees. W2 will turn on when we are 1 degree plus the Y2 differential plus the W2 differential below the set heat room, and it won't turn off until we're at the set heat. The backup delay, or the W2 delay, is the minimum amount of time that the first stage, W1, and the heat pump must be operating before W2 can turn on. Now, two conditions have to be met for W2 to turn on. Firstly, we have to have that W2 differential met, and secondly, the W2 delay time must have expired. We can configure this for auto mode, in which there is no additional delay, or for a time ranging between 5 to 180 minutes, so we can hold off that W2 for up to 3 hours if we want to. Or we can put it into override mode, in which W2 will only turn on when we're in emergency mode. So in that case, our W2 really would be a backup source of heat. Now, the backup delay is not used if we are in emergency mode. In emergency mode, only W1 and W2 operate. So we're not going to enforce an additional delay on W2 when we only have W1 and W2. We'll bring W2 on as needed. Our Y2 delay is the amount of time that the first stage compressor must operate before the second stage compressor can turn on. And similar to W2 relay, the Y2 relay will only close to turn Y2 on if two conditions are met. The first is the Y2 differential has been met, and the second is the Y2 delay time has expired. We can configure this for auto mode, in which there is no additional delay, or for a time ranging from 5 to 180 minutes. So again, we can hold off that Y2 for up to 3 hours if we choose to. Our ventilation mode allows us to configure the fan operation to work outside of heating and cooling if that's what we want. So we can configure the ventilation for 10 to 90% of on time per hour, where each 10% is equal to 6 minutes of on time for that hour. We can put it into auto mode, where it will run only during heating and cooling, or we can turn it on, in which it's on 100% of the time. So ventilation is also known as intermittent fan, if you're more familiar with that term. The settings we've looked at so far are in the setup menu. These are where we can find the essential settings for the 557. The other menus that we'll look at today are the set temp menu and the toolbox menu. Additional menus are the time menu, schedule menu, display menu, scenes menu, and monitor menu. These are pretty self-explanatory. They're very easy for the user to set up and understand, so we're not going to review them in today's webinar. The set temp menu is where you program your heating and cooling temperatures for each scheduled event. So here is where we're going to configure the set heat room for the occupied, unoccupied, and away time, the set cool room for the unoccupied, occupied, and away time. It's also where we set up our minimum and maximum limits. So here's where we program our floor min and our floor max for occupied, unoccupied, and away. The set temp menu is also where we're going to program our ventilation and humidity control preferences. So here is where we set up our relative humidity minimum and maximum percentages for the occupied and unoccupied times. Also where we're going to configure our ventilation. So we turn our ventilation mode on or off in the setup menu, and we configure it in the set temp menu. So this is where we set it to auto, a percent on time, or on. Our toolbox menu is very useful for troubleshooting. As a tech person, this is where I start when I'm trying to diagnose a problem on a 557, because it provides so much information to me. Here is where I can configure the access level. So obviously I need an installer to configure the settings of the 557, but once I'm done setting it up, it is advisable to reduce that access level to user, limited, or secure. That way we can try to prevent homeowners from changing settings inadvertently that end up triggering errors on the system. Status info provides a lot of information. This is where we can see if the 557 is a normal operation, if it's an override W1. So this message would appear when we're in radiant floor warm weather shutdown. And we talked about that in greater detail in the first webinar. To review, radiant floor warm weather shutdown holds off the radiant floor during the shoulder seasons of spring and fall. And we do that so that we're not charging up the floors in the early morning to have them radiate heat that's not necessary in the afternoon. Instead, we'll use our heat pump. Status info is also where we'll see if we're in floor cooling operation, if we're in warm weather shutdown or cold weather shutdown, if we're in optimum start, if we've hit a floor min or a floor max, if hydronic heat has been forced off. And this happens if the 557 as an air group master is in cooling mode and it is holding off that hydronic heat while cooling. It also tells us if we're in the interlock wait period between heating and cooling. The toolbox menu is where we can find the addresses for the 557. Also where we can find the device count. So this is telling us how many thermostats and set point controls the 557 is currently communicating with. In the toolbox menu, we can also offset the room temperature. So if we've installed the 557 in a location where it might be subject to airflow that is resulting in an inaccurate measurement of the room temp, then we can offset it by either 5 degrees below all the way up to 5 degrees above the actual measurement. Likewise, we can offset humidity from minus 10% all the way to plus 10%. A very useful item in the toolbox menu is the error history. So what this does is it displays the last 5 errors that have occurred on the thermostat in the past 30 days. And each error is date and time stamped. So in this example on the screen, we have our first error in the history that occurred on January 29th at 7:30 p.m. And this screen would actually toggle to a screen that shows me the exact error message. If I no longer want that error message to be held in the history, I can press cancel. The toolbox menu is also where I can load the factory default. So if I want to start afresh, I can go in here to load the defaults and maybe configure settings from there. To summarize today's presentation, we started by looking at relative humidity. What is it? How do we control it? We looked at the humidification modes and the dehumidification modes and how each mode is particular to a certain type of equipment so that we understand how we're going to configure the 557 for the equipment and the application that we're using. We looked at the essential settings and the electrical wiring for each of the 557 applications that are featured in the data brochure and that we went through in our first webinar. We talked about all the different menus of the 557, and we had a focus on the set temp menu and the toolbox menu and looked at the items that we can configure in the set temp menu and what kind of troubleshooting we can do in the toolbox menu. I hope you found this information useful and informative. Keep in mind that additional information can be found on our website, www.tekmarcontrols.com, where you can download the data and application brochures for the 557. We hope that after learning how the relays can be wired and configured, that you have a strong sense of the versatility and the superior functionality of the 557 thermostat, and that you can confidently determine if this 557 thermostat is the right choice for your application. The tekmarNet Thermostat 557 is the best in heat pump and radiant floor control, and for a variety of other applications as well. We offer the better design, the better control for better systems. If you have any questions or comments, please send us an email to the address learn@tekmarcontrols.com. We at Tekmar are very proud of the strength of our customer support team, and we'll get back to you as soon as possible within the same day. Thank you for joining me in this webinar presentation of the 557. My name is Elizabeth Brown, and I look forward to hearing from you. I hope you have a great rest of your day. Bye-bye.